Let's see how to create a classic animation in Manim. This is a video that's different from any video I've done before. I was inspired by the Talking Maths in Publics folk. Here's a website you can see. They've created a challenge which they're calling the TMIP, Talking Maths in Public Animation Generation Collaboration. It's a community project to create and publish process videos of mathematical animations using a range of different techniques and processes. The March prompt, which is the very first one, is to create the classic circle and sine curve animation. They want to see it in different things, and since I animate using 3 Blue 1 Browns or Grant Sanderson's Python library ManimGL, I figured I'd make this video to show how I might create this animation using Manim. If you're not familiar with this animation, I just searched for sine curve from circle animated GIF, and I found this one on Wikipedia, where if you click it and wait for just a second, it shows that as you traverse around the unit circle and measure the y coordinate, you map out the sine curve. So I wanted to take this classic animation, which exists in a lot of amazing forms, and there's been some amazing other people as part of the Talking Maths in Public doing this, but I wanted to try and show my own version. So let's see what we've got, and let's give it a try. Okay, so here's my attempt to do this in real time. This is not something I'm super skilled at, so bear with me. You can see I have a blank Python file opened. I have imported the appropriate Manim library here. And then these two lines sort of start off the Manim code that I need. After that, I'm just gonna sort of think about what I want to see and hopefully make it so. So the first thing that I'm gonna need is I am gonna need a unit circle to be drawn. There is a built-in way to draw a circle in Manim, but I'm instead going to parameterize it and use the parametric curve, which is also something built in Manim. So I'm going to call it circ. It's a parametric curve object, and this just needs a couple of pieces of information. So it's lambda u, and then it takes in the parameters. And the parameters are the coordinates or the parameterization of the circle, which is given by the cosine of u, the sine of u, and 0. Manim needs 3 coordinates if you're not using something special, and we're going to be drawing in the flat plane, so our z coordinate will always be 0. We also have to tell it where the parameter starts, so the minimum value for the parameter is 0, and the maximum value for the parameter is 2 times pi. This makes sense because we want to draw the full circle from 0 to 2 pi. With any luck, that particular object, if I do self.play, and then in ManimGL you use show creation, circ, and if I were to go try and render this, you should see that what we have is our circle drawing, which is pretty nice. Next, we should need our sine curve. To do that, I'm going to draw it on an axis system, and ManimGL has a nice axis system built in. So I will call it sine axis, and the command is its axis. This needs a couple of things as well. You have to set the x range, so this will be the labels or the scale on the x coordinate. I'm going to go from 0 to 7 by a step unit of 1. I've chosen 7 because I'm going to map the sine curve out to about 2 pi first. For the y range, the sine curve outputs between -1 and 1, so -2 and 2 with a step unit of 1 should be more than enough to see it. I have to set a height. I'm going to set the height equal to 4 and the width equal to 7. And that way, since my x range is 7 units and my y range is 4 units, everything should be in a 1-to-1 aspect ratio and look pretty good. The last thing that I like to do, you don't have to do this, but I'm going to set my configuration for my axis. So if we're at all lucky, we should be able to draw the circle. We should be able to draw the sine axis. And so I go back to my code here. I run it again, and in real time I see the circle, and then I see the axis being drawn. Notice though that the axis and the circle drew on top of one another. Really I want them to draw next to each other. So this is pretty easy. I take sine axis and I just say, look, I want it to be next to the circle, and I want it to be on the right, and I'll set a buffer of about 1. Now if I go back in here and run it, we should see the circle being drawn, and then we should see the axis drawn next to it. Now, I don't like that because the axis is too far to the right and things aren't centered. So to handle that and the fact that I'm going to need the camera a little bit more in this video, I'm going to rename the camera, which is usually called self.camera.frame. I'm just going to rename this camera frame to frame. And now I'm going to take the frame and I'm going to move it. And I want to move it to the group. So I'm grouping together the circle and the sine axis. I've got a typo here. There we go. If I take those plays afterwards and put them after that, then we should see that it draws the circle and then it draws the axis system. So we have our circle, we have our axis system. Now we have to draw our sine curve. The difference between that and the circle is it's still going to be a parametric curve, but now my sine curve is going to be a parametric curve. So I'm going to copy and paste that. Still a parametric curve, still lambda u. The difference this time is I want to draw it on the axis system. And so I say sine axis dot c2p. On the axis system that's two-dimensional, I don't need 3 coordinates, and I need to parameterize the sine curve, which has x coordinate u, y coordinate sine, and then I'm going to have it go from 0 to 2 pi again. And with any luck, that put it directly on the sine axis. And so if I go to the sine curve and run it, we should see the circle being drawn, we should see the axis being drawn, and then we should see the sine curve being drawn from 0 to 2 pi. That's the first thing that we need. We've at least got the picture set up now. Now we want to work on connecting the circle to the sine curve. And I have a couple things I like to do to enhance the animation. So the first thing I want to do is I want to focus in on the circle. What I would like is to have a radius draw and then sweep around as the circle is drawn. To do this in Manim is not so bad. So how am I going to do it? The first thing I'm going to do is I'm going to draw my radius. My radius is going to be a line. So it's a line object. The circle is centered at 0, 0, 0, so it's going to be from there. And it's going to end at 1, 0, 0 because it's a unit circle. So I should be able to draw that radius, which I'll do first. So show creation radius. But now I do the interesting thing. As I said, that's going to draw the radius right here. But now as the circle draws, I want the radius to sweep around so it looks like the radius is drawing the circle. To do that, I use an object that I'll use a few times in this video called an updater. And so I'm going to define a temporary radius updater, which I'll call temp radius up. It takes in an object, which we call mob for M object in Manim object. And then what I'm going to do is I'm going to have that object become the line. So it's going to become a line. But the only difference is still starts at 0, 0, 0 because I want it to be a radius. But now I want it to end. I want the end of the line to be at the end of the circle. So I say circle.getEnd. And I'm going to add that updater to the radius. So I say radius.addUpdater, temp radius up. And now when I draw the circle, we should see the radius draw. And as I draw the circle, the radius stayed attached to the end of the circle. So as it drew, it stayed there. Once I draw the circle, I'm done doing that. So I can take the radius and I can remove the updater. And that's because I'm going to need the updater a little bit later. So I remove that temporary radius. And again, I can make sure by doing a tag in Manim of -s, it will just show me the very end scene, the very last scene. And so everything looks like it should be pretty good and it renders with no errors. So that's good, but now I want to do something a little more interesting. So what I want to do is I want the sine curve not to draw out in its entirety. I want it to draw out slowly as the radius sweeps around. So what I'm going to have to do is I somehow need to figure out a way to connect the sine curve and the radius to the same kind of updater. To do that, I'm going to build in something called a value tracker. And so I'm going to call it theta because it's going to represent my angle. It is a value tracker object, and the value tracker needs an original value. Typically, I'd go with 0 because I want my angle to start at 0. I've had a few problems with that sometimes before, so I go with a really small number like 0.0001. Now the difference is my sine curve, I don't want it to start at 0 and end at 2 pi anymore. I want it to end at where theta is. So right now, if I were to draw this, because the value of theta is 0, it wouldn't draw this at all. So if I go in here and I try to draw and see what it is, you should see that now it didn't draw my sine curve, and that's because my sine curve now starts at 0 and ends at essentially 0, so I'm not seeing it. I want to do the same kind of thing to the radius, but first I have to realize that even if I were to do this and change the sine value, this sine curve is not updating all the time. So I need to, after I draw the sine curve, and I no longer need to draw it, I can just add it because it's not actually going to show up. Now I'm going to define a new updater. So I'm going to define my sine curve updater. It's going to take in an object. and it's going to take that object, and that object is going to become this thing again. So same exact thing. It's just now this depends on the theta value. So now we have this updater, sine curve up, and we see that it should end up making it depend on that. Now the only thing I have to do before doing that then is to take my sine curve, add my updater, sine curve up, and now I should be able to take my value tracker, which is called theta, and I should be able to animate it and set its value to something else. So in particular, 2 times pi. So before it wasn't drawing the circle, but now when I go drawing the sine curve, now when I go draw it, it draws that sine curve. And you can see that just by changing the value I animate it to, if I animate it just to pi, it should only draw the sine curve up to pi. And it ends there. Okay, so right now I'm drawing the sine curve based on this parameter. And what I want to do is I want to attach that same parameter theta to rotating my radius. So I'm going to take my radius and I'm going to updater, and I'm going to create a new radius updater. This time it's going to take my radius. It's still going to center it at 0, 0, 0. But now where is it going to put the end? It's going to put the end where I want. The cosine of theta dot get value. So cosine of theta dot get value, math dot sine of theta dot get value, and then 0, and then I got to close the line, and then I got to close the become. And hopefully I take my radius and I add my updater of radius up, and hopefully now when we run this, we see the circle draw, we see the axis draw, we draw that, and notice that time the radius also rotated at the same time. And so if I go to 2 times pi, I should get there pretty close. So let's see it slowly. Draws the circle, draws the axis, and there we go. The radius rotated around the circle 1 full time and drew out the full thing. So we're just getting pretty close to where we want. There's a few things that I'm missing that I think I might like. The first thing that I might like is that I think it makes sense to have a label on the x-axis and the y-axis. So the first one I will do is the x label, and it's just a text command. Because I want it to be text, I'll do text, and in the text I will call this the angle. I'm going to scale it because I think it's going to be too big at full scale. Scale it 3/4 its size, and then I'm going to put it next to the axis, the sine axis, sine curve, sine axis to the right. I'm going to create a second one as well. It's going to be the y coordinate, and I'm going to put that to the top of the sine axis, but I think that I'm going to have to shift it left 3 times left so that it looks about the right place. I'm going to call that label 2. And then to write these text values, I guess I need to do those back here, cut that out, right when I draw the axis system. So here's where I draw the axis system. So there when I draw the axis system, now I'm going to self.play, I'm going to write. So I'm going to write label 1, and I'm going to copy that, and I'm going to write label 2. And then sometimes it's nice to have a bit of a pause. So in Manim, you can use the command self.wait. So let's see what this does. It should have drawn my axis, or it should draw my circle, should draw my axis, should label angle and y coordinate about right. And then boom, there we go. So now I want to draw some connection between the radius and the height of the sine curve. And in order to do this, I need another line. And so the line that I'm going to use is going to be a connector line. So I'll name it connector. It's a line. And what I want it to do is I want it to connect the end of the radius to the end of the sine curve. And so it's going to be a line that starts at the end of the radius and ends at the sine curve's end, get end. Again, that will only do it one moment in time. So I'm going to do the same kind of thing I did here. I'm going to create a connector updater, and I'm going to grab this line. I'm just going to repaste it. It's saying the connector is just going to keep being updated this way, and I'll call that connector, and instead of that I'll call it connector radius. And now I need to draw that connector. So self.play show creation. I'm going to show the creation of the connector line. And then I'm going to add that. Now, one thing I think is going to be nice is if I actually make this a dashed line instead, so that it looks a little different, a little interesting. I'll change that. And just so we can really see it, I'm going to set the stroke to be yellow, and the usual width is 4. I'll set it a little thinner there, and I'll make sure that that ends up in my updater as well. So we've drawn the connector, done it. Let's see what this does. So hopefully what this should do is draw my circle using the fun radius, draw the axis, label the axis, and then draw our dashed line, and then there we go. Notice that the dashed line connected the y height to the end of the thing. Now that's a little fast. I'm going to run time, and I'm going to let this take about 6 seconds, so that it basically 1 second for every radian. And maybe that'll be a bit slow, and we can speed it up, but we'll watch it here. I think for that first one, that's actually pretty nice. It shows exactly what's going on, and it maps out the y height there. So we've pretty much done what I set out to do, but I wanted to sort of try to do 1 or 2 more interesting things, especially since now Manim makes these things a little bit easy. So the first thing I'll notice is that just by changing this value of 2 pi, I can make that sine curve really, really long, and I can show the periodic nature. In order to do that, I need a bigger axis. And so the first thing I'll do is I'll go grab my sine axis and where it is, and I'm gonna, so I'll wait here for a second, pause it, maybe 2 seconds. Now I'm gonna create a new axis that's gonna go basically out to, we'll go out to 10 pi, 32, and now I need my width to be 32. I've called this sine axis 2, I'm gonna put sine axis 2 there, and basically what I'm gonna do is I'm gonna fade in my new axis, and right after that I'm going to remove just right away my old sine axis. Now that shouldn't matter because you shouldn't even see it, and so if we go to the end, you should see it will still have, now it looks like it has this bigger axis. Now notice angle and y coordinate aren't going to be in the right place anymore, so I'm also going to have those fade out at the same time. So I'll have my labels fade out, I don't need them anymore. And this shows you that you can put multiple commands in the same play, and those will all happen at the exact same time. So why am I adding this bigger set of axis? What I want to do is I would like the camera to zoom out, and I would like to keep showing the sine curve being shown over and over again. The fun way to do that is to use what is called sort of a lagged animation. So the lagged animation goes like this: self.play. So we've got our self.play. For a little spacing, I'll do this way. It's called a lagged start. So I'm going to do a lagged start. The first thing I'm going to do is I'm going to animate my frame. I want my frame to get wider. Set width. And I want it to essentially get as large as the new axis. So it's going to get that width of that. I'm going to make it a little bit bigger, 1.2. And then I know from experience that that's going to lose the circle, so I got to shift somewhere about 12 times right. And at the same time then, I also want to take my parameter theta, I want to animate it and set the value to, what do we say, 10 times pi. And then I need to set a lag ratio here. You have to play around with this a little bit, but I think 0.2 is going to be pretty nice. That's the ratio. It means it's going to start zooming out, and then it'll start start animating the theta after about 0.2% of the time. And then we do need a runtime on this, so I'll runtime it at about 15 seconds. Let's make it 12 seconds and see what that does. So you can start the animation at the middle with the tag sort of N6. This should start at the 6th frame, and the 6th frame basically draws my, okay, so here we go drawing my first sine curve from 0 to 2 pi. We should see angle and y coordinate fade out while the new axis fades in. And now the frame starts zooming out. And after it starts zooming out, we see that the circle starts rotating over and over again, showing that the y coordinate is periodic in the unit circle. And that's why the sine function is periodic and keeps going. And so we can map this all the way out to 2 pi. And it looks like our spacing ends pretty well. I can see the end of the axis and I can see the circle. And it's pretty well centered. So this is pretty good. I like the way that this ended up working out. But I have even one more idea that I want to do. And that is, what I'd like to see is I'd like the radius to keep circling around, but I'd like to see like sort of a vertical y height measuring the y coordinate. And over here in the sine function, I'd like to see sort of the same vertical yellow line traversing through the sine function. So the first thing that I have to do is I need to get rid of a bunch of this stuff. So I'm going to take my connector and I'm going to remove the updater. because I want to fade out the connector. I'm done with that now. So there was the connector updater. And then I'm going to fade that out. So self.play, I'm going to fade out the connector. If you don't remove the updater, there's a chance it just keeps staying there. So I want to fade out just to do it. I'm also going to remove the updater from the radius temporarily. So radius had this updater called radius up. I'm going to remove that temporarily. And my sine function, I don't want it to redraw. So I'm going to take my sine curve and I'm going to remove the updater. And it was called sine curve updater. So I'm done with all of those. And basically, if I were to go look at that, go to the end, at the end, everything should still be there. And now what I want to do is I want to reset my theta value. So I want theta to be set back to 0, essentially. Like I said, what I hope to do is draw a vertical line over here in the circle. That's going to have a height of the sine of theta. And I'm going to draw a vertical line over in the sine curve as well that's also going to have a height of sine of theta. So there's going to be these two sine lines, which I will call sine line 1, or sine line and probably sine line 2. The first one is a line. Well, where's it going to be? It's going to start at the end of the radius. And it's going to go from there, radius.getEnd, and I'm going to subtract off the sine coordinate in the y component. So math.sine of theta.getValue, and then 0. So this should draw a line from the radius end to the radius end minus the sine of the value where I'm at. So sometimes that'll be gone and won't be there. I take the same thing, the sine line. I'm going to draw sine line 2. Now this one's going to be over in my axis system. So it's going to start at sine axis dot C2P. And where's it going to go? It's going to start at 0. No, it's going to start at the theta angle because that's that. And its y coordinate is 0. So it starts there. And I need it to end at theta, but not 0 anymore. Now I'm going to do math.sine theta.getValue parentheses. If I were to add both of these right now, add sine line 1 and sine line 2. If I were to add them, you won't see them. And that's because they've both been drawn, but they both have a height of 0 since my theta value is set to 0. What I really want is I want them to update all the time. So not only am I going to have to add them, I'm going to have to define updaters for each one. So sine line up of Manim object, and the object is going to become, real quick, I guess before I do that, I should set the stroke here. I decided I want these to be a little thick, so yellow, they're going to be bright yellow, and I want them to be a 6 width because I'm zoomed out now, so maybe I better do that so that I can see them a little better. Now, the first sideline just gets replaced with this, so I just say update it with what it is, copy this, and create a second one, which will be my second sideline. So sideline 2 updater, and then copy this and paste that in there as what it's going to become. And then I have to add those updaters. So I have to add sine line, and I need to add the updater. And I'm going to add sine line up. And then I'm going to do the same thing with sine line 2, and it's sine line 2 up. And now we're just about ready for the magic, so I'm going to wait 1 second so I can watch it. Now we just need to take our theta value and we need to animate it. Right now it's currently set to 0, and I want to animate it to be the full length, which is 10 times pi. And I'm going to run time in about, let's take about 15 seconds here. So we took 12 seconds to do that. Yeah, 15 seconds looks like it should be right. And then I'll do a little bit of a wait at the end. We'll say wait 3 seconds. So let's see what this does. I'm going to start at N7. So I'm going to start at the 7th scene. The 7th scene was where I zoomed, or 7th scene is where I do the sine function, draw it in terms of the circle. And now I am going to zoom all the way out, continue drawing the sine curve, and then we're going to hope that this works out well, meaning we're going to hope that it does all of this again, rotates all the way around again, but this time I hope to see a yellow line branching down off of the sine curve, off of the radius, and I hope to see a corresponding yellow line of the same length work its way through the sine curve over here. So first we fade out the connector, and now we see as we start to rotate, didn't quite do it right. So something's wrong here. And the thing that's wrong is I removed the updater from the radius, but forgot to re-add it. So that was temporary so that I could reset this, but now I want to make sure that my radius is still added there. So I want to re-add the updater there, and with any luck, that will work. So it looked to me that that was about scene 11. We'll see where we're at. So scene 11, we fade out the connector, and now let's see if this works this time. There we go. I added the radius updater, so now the radius is spinning. The yellow line is the height of the y coordinate, and on the other side, the yellow line is traversing through the sine curve, showing exactly the same y height. So that did just about what I was hoping that it would do. That's my version of the classic animation that the circle is related to the sine curve. That is the y coordinate as you traverse the unit circle will be the sine function. So I hope you've enjoyed that, and I hope maybe it works. I guess the only thing left for me to do is to try to create the full high definition video of this so that we can see it working. In order to do that, I use a similar command. I render it, but this time I had two tags, --UHD. That's going to render it in ultra high def, and then -W is going to write it. So I'm going to run this now. Okay, that took about 4 or 5 minutes to get the high def rendering, but I skipped through most of it. This is now just the last scene, scene 14, where I'm just waiting 3 seconds, and then we'll see what we created here and see if it looks about how we expected. So you can see it finishes up and it produces this video right here, which I'll open. It's 48 seconds. We see our circle draw. We see our axis draw with its labels, angle and y coordinate. And then we have our dashed line showing that the height of and at the y coordinate in the unit circle is the sine function. We should now see our labels fade out and our large axis fade in. And as we zoom out, we continue rotating around and around, creating the periodic sine curve, seeing that it just goes on forever since it's the y coordinate on the unit circle. Finally, we have our last little bit where we faded out the connector, and then we show the y height as this vertical line as we keep going through and through the sine curve and around the circle, and they match. At the end here, everything sort of slows down, and we have about 3 seconds of wait time before the video ends. So here's that animation one more time. I hope you learned a little something about animating with Manim and that this inspires you to try something on your own. And I want to thank the Talking Maths and Publics folks for encouraging me to participate in this particular endeavor of showing how to use various math tools to animate mathematical ideas. If you like this, let me know in the comments, and I'll try to do more in the future as they continue on that path. And if you need to see the code, I'll link to the code in the description so that you can try modifying it and drawing it in a way that you see fit. Thanks for watching.